Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animals and animal product. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Barishal Cadet College. Now, in this class, I am going to discuss polynomial and polynomial equations from chapter 4 of your book, Learning Outcome. After the class, you will be able to determine general solution of quadratic equations, explain discriminant, determine and apply the relation between roots and coefficient of quadratic equations from quadratic equation with given roots. Now, steps to solve quadratic equations. A quadratic equation is of the form of ax squared plus bx plus c is equal to 0. This is a general form of quadratic equations, where a, b, and c are real numbers, also called numeric coefficients. Here, x is an unknown variable for which we need to find the solution. X squared plus bx plus c is equal to 0. This is our general formula for quadratic equation, general equation for quadratic equation. Here a, b, c are real numbers or numeric coefficients, and x is an unknown variables. We need to find the solution for x. The formula to find the solution of the quadratic equation is given by x is equal to minus b plus minus root b square minus 4ac divided 2a. This is our required formula to solve a quadratic equation. Remember this formula carefully. In the above equation, that means this equation, b square minus 4ac is called the discriminant of the quadratic equation because it determines the state and nature of the roots of the equations. Here, b square minus 4ac is called discriminant of the quadratic equation ax square plus bx plus c is equal to 0 because it determines the state and nature of the roots of the equations. Now, variations and nature of the roots of the quadratic equation depending on the conditions of the discriminant. Let a, b, and c are rational numbers, then if b square minus 4ac greater than 0 and is a perfect square, then the two roots of the equation are real and unequal and rational. This, again I repeat, if b square minus 4ac greater than 0, that means if discriminant greater than 0 and is perfect square, then two roots of the equation are real, unequal, and rational. Now condition number 2, if b square minus 4ac greater than 0 but is not perfect square. The previous one is b square minus 4ac greater than 0 and perfect square, and now b square minus 4ac greater than 0 but is not perfect square. Then the two roots of the equation are real, unequal, and irrational. This is changed here, the rational, and here the irrational. Remember these two things carefully. Now condition number 3. If b square minus 4ac is equal to 0, hence the two roots of the equation are real and equal. In this case, x is equal to minus b by 2a. Again, I repeat, if b square minus 4ac is equal to 0, that means if discriminant is equal to 0, then the roots of the equation are real and equal. In this case, x is equal to minus b by 2a. Now, condition number 4, if b square minus 4ac less than 0, then the roots of the equation are not real. In this case, the two roots are always conjugate complex and imaginary to each other. These lines remember carefully. If b square minus 4ac less than 0, that means if discriminant less than 0, then the roots of the equation are not real. In this case, the two roots are always conjugate complex. That means if conjugate complex or imaginary to each other. These four conditions are needs to solve some problems. That's why you remember these four conditions. Now let us try to solve some questions. Now question number 1. First, for what values of k the roots of the equation k minus 1 into x square minus k plus 2 into x plus 4 is equal to 0 real and equal? Now solution. Given that k minus 1 into x square minus k plus 2a into x plus 4 is equal to 0. The two roots are real and equal if the discriminant is 0. So for what value we find, for what values of k? We find the value of k, and the other given conditions are real and equal. When the roots are real or equal, the roots of the equation are real and equal if the discriminant is 0. That's why we can write minus k plus 2. Here we know ax square plus bx plus c is equal to 0. This is our general equation of quadratic equation. If we compare these two equations here, so k minus 1 means a and minus k plus 2. This means b. That's why we know b square minus 4ac. B square means minus k plus 2 whole square minus 4 into a means k minus 1 and c means 4 is equal to 0. Now we know a plus b whole square is equal to a square plus 2ab plus b square. Applying this formula here, then we can write k square plus 4k plus 4 minus 16k plus 16 is equal to 0. Now after calculating, we can write k square minus 12k plus 20 is equal to 0. Now here middle term, that's why you can write k square minus 10k minus 2k plus 20 is equal to 0. Now k, here k common, then we can write k minus 10, here minus 2 common. That's why we can write k minus 10 is equal to 0. Now k minus 10 into k minus 2 is equal to 0. That means k is equal to 10 or 2. This is our required value for k. So remember this condition. Here we apply the roots of are real and equal. Here given the roots real and equal. That's why we can write the discriminant is 0. That means b square minus 4ac is equal to 0. Now another question. For what values of k the polynomials k plus 1 x square plus 2 into k plus 3 into x plus 2k plus 3 will be a perfect square? So where given equations, the given expressions will be perfect square if the discriminant is 0. That's why we can write b square minus 4ac is equal to 0. That's why we can write 2 into k plus 3 square minus 4 into k plus 1 into 2k plus 3 is equal to 0. Now Here applying a plus b whole square formula, then we can write 4 into k square plus 6k plus 9 minus 4. And if we multiply these two terms, then we can write 2k square plus 3k plus 2k plus 3 is equal to 0. Now multiplying 4 here, then we can write 4k square plus 24k plus 36 minus 8k square minus 20k minus 12 is equal to 0. After calculating, we can write minus 4k square plus 4k plus 24 is equal to 0. Now minus 4 common. Then we can write k square minus k minus 6 is equal to 0. Now here middle term, then we can write k square minus 3k plus 2k minus 6 is equal to 0. Now k common, then we can write k minus 3 here plus 2 common. Then we can write k minus 3 here, k minus 3 common. Then we can write k minus 3 into k plus 2 is equal to 0. That means k is equal to minus 2 and 3. This is our required value of k. Now another formula. If the roots of the quadratic equation ax square plus bx plus c is equal to 0 are alpha beta, here the roots of the equation are alpha beta, then the relation between the roots and coefficient we get the sum of two roots. That means alpha plus beta is equal to minus b by a, and product of the two roots, that means alpha beta is equal to c by a. Now if the roots of the quadratic equations are alpha beta, then we can write the quadratic equations is x minus alpha into x minus beta is equal to 0. Here these lines you remember carefully. If the roots of the quadratic equations are alpha beta, that means the root of the equations are, that means x is equal to alpha and beta. That's why we can write the quadratic equation is x minus alpha into x minus beta is equal to 0. Now if we multiply these two terms, that we can write x squared minus alpha plus beta into x plus alpha beta is equal to 0. Now the new form of the quadratic equations will be x squared minus sum of the two roots into x plus product of the two roots in is equal to 0. We use this formula when solve problems. So these things you remember, always remember these things. That means if the quadratic equations are ax square plus bx plus c equal to 0 and the roots alpha and beta, then the sum of the roots is minus b by a and product of the roots c by a. And if we form a new equation, then we use this formula x square minus sum of the two roots into x plus product of the two roots is equal to 0. Now we use this formula to solve some questions. Now, if the roots of the equation ax square plus bx plus c is equal to r alpha beta, to form the equations whose roots are alpha plus 1 by beta and beta plus 1 by alpha. Now solutions. The root of the equation ax square plus bx plus c is equal to 0 are alpha and beta. Then we know sum of the roots is equal to minus b by a and product of the roots is alpha beta is equal to c by a. And now here given another roots alpha plus 1 by beta and beta plus 1 by alpha. That's why you can write sum of the roots alpha plus 1 by beta and beta plus 1 by alpha. Now alpha plus beta, here alpha beta LCM alpha beta, then we can write alpha plus beta. Now we're putting this value here because we know alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Then after calculating, we can write minus b by a minus b by c is equal to minus bc minus ab by ac. Now product of the root alpha plus 1 by beta into beta plus 1 by alpha. After multiplying, we can write alpha beta plus 2 plus 1 by alpha beta. We know alpha beta is equal to c by a. Now we can write c by a plus 2 plus a by c. Then here is same ac. Then we can write c square plus 2ac plus a square. Here c plus a whole square by ac. Now the required equations, we know the required equation is x square minus sum of the roots into x plus product of the roots. So already we find the product of the roots this term and sum of the root this term. Now putting this value here, then we can write x square into sum of the root into x plus product of the root is equal to 0. Then after calculating this, we can write ac x square plus b into c plus a into x plus c plus a whole square is equal to 0. This is our required equation. Now another questions. Find the equation whose roots are the sum and absolute value and of the difference of the roots of the equation x square minus 2x plus a square minus b square is equal to 0. Find the equation whose roots are sum and absolute value and difference of the roots the equations x square minus 2x plus a square minus b square is equal to 0. Now let the root of the given equations are alpha and beta. So we know sum of the root, that means alpha plus beta is equal to minus b by a. Minus b by a, that means minus 2a by a means 1. That's why you can write 2a, and alpha beta is equal to c by a. That means a square minus b square by 1. That's why you can write a square minus b square. And here another condition, given conditions. So the roots of the required equations is mod of alpha plus beta and mod of alpha minus beta, because here given the roots are sum and absolute value of the difference of the roots. That's why you can write mod of alpha plus beta plus mod of alpha minus beta. Now alpha minus beta is equal to plus minus root a alpha plus beta whole square minus 4 alpha beta, because we know a minus b is equal to root a plus b whole square minus 4ab. Now putting this value here, then we can write 4a square minus 4 into a square minus b square. After calculating this, we can write plus minus root 4b square, that means plus minus 2b. So positive value of alpha minus beta is 2b. Therefore, sum of the roots is 2a plus 2b, 2 common, that means 2 into a plus b, and product of the roots 2a into 2b, that means 4ab. So our required equation is, we know x square minus sum of the roots into x plus product of the root. Here sum of the roots 2 into a plus b into x and product of the root 4ab. Now putting this value here, then this is our required equation. Now another questions. If the root of the equation ax square plus bx plus c is equal to 0 are alpha beta, express the roots of the equation cx square minus 2bx plus 4a is equal to 0 in terms of alpha beta. That means here given the roots of the quadratic equations alpha beta, now we express this equation in terms of alpha and beta. Now given the root of the equation ax square plus bx plus c is equal to 0 and root alpha beta. So we know sum of the roots is alpha plus beta is equal to minus b by a and product of the root c by a. Now here given cx square minus 2bx plus 4a is equal to 0. Here denominator a, that's why we divided this equation by a. Then we can write c by a into x square plus 2 minus b by a into x plus 4 is equal to 0. Here c by a means alpha beta and minus b by a means alpha plus beta. Now putting this value here, then we can write alpha plus beta x square plus 2 into alpha plus beta into x plus 4 is equal to 0. Now, after calculating, we can write alpha beta x square plus 2ax plus 2 beta x plus 4 is equal to 0. Here alpha x common, then we can write beta x plus 2. Here 2 common, then we can write beta x plus 2. After calculating, we can write x is equal to minus 2 by beta minus 2 by alpha. This is our required root. So root are minus 2 by alpha and minus 2 by beta. Now another question. If the root of the equation ax square plus bx plus c is equal to 0 and are alpha beta, express the roots of the equation ac into x square plus 1 minus b square minus 2s into x is equal to 0 in terms of alpha beta. So solution, the roots of the equation ax square plus bx plus c is equal to 0 are alpha or beta. That's why you can write alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Now here given equation ac into x square plus 1 minus b square minus 2ac into x plus is equal to 0. Here given denominator a, that's why we divided a this equation. Then we can write c divided a square. That's why you can write c by a into x square plus 1 plus b square by a square minus 2c by a into x is equal to 0. Now here we can write minus b by a whole square minus 2 into c by a into x. Then we know c by a, that means alpha beta, and minus b by a, that means alpha plus beta. Here putting this value here, then we can write alpha beta into x square plus 1 minus alpha plus beta whole square minus 2 alpha beta into x is equal to 0. We know alpha plus beta whole square is equal to, we know alpha plus beta whole square minus 2 alpha beta is equal to alpha square plus beta square. That's why you can write alpha plus b alpha beta x square plus alpha beta minus alpha square plus beta square into x is equal to 0. Now after calculating, we can write alpha beta x square minus alpha square x minus beta square x plus alpha beta is equal to 0. Then alpha x common and here beta common. Then we can write beta x minus alpha into alpha x minus beta is equal to 0. Then x is equal to alpha by beta and beta by alpha. This is our required root. Now this is your homework. If the root of the equation ax square plus bx plus c is equal to 0 are alpha beta, from the equation whose roots are 1 by alpha, 1 by beta, and question number 2, 1 by alpha square, 1 by beta square. That's all for today. If you have any query in this, you can ask that in the comment section. Lastly, I would like to remind you the most important things. In this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.